Here's how we solve this. Looking back at the problem, we might wonder, how did we justify our steps? And it's fairly simple. Starting up here, we want to isolate the x by itself. In order to get x by itself, we need to do the opposite of a natural log. The opposite of natural log is e. So what we're going to do is do e to the power of this natural log, but the problem being, if this becomes the new power on the function e, we need to do it to every one of the components in the inequality. So this -3 will become the new power on e, the natural log is the new power of e, and 7 is the new power on e here on the right side. The whole game plan with this works because e and natural log are inverse functions. Inverses cancel out, counterbalance. So these are effectively negating each other, and they just return x. They spit out whatever's inside. These other numbers are going to stay the way they were. Of course, the -3, we can rewrite this as 1 over e to the +3. And at the very end, if we wanted to put this into interval notation, we would get this range. Remember, at the end of the day, these are talking about x values that make the natural log of x stay wedged in between -3 and +7 as its heights. To get a better view of what we're doing, we'll go ahead and throw this into Desmos. You can do a search for Desmos in Google or Yahoo, and this will be the address, desmos.com. It's free, it's online, and here's what we wanted to do. If we think about our inequality, one of the functions was a height of -3, so we'll type y as -3. The middle function was natural log of x, and the upper bound was a height of 7. We can't just type 7 in because it doesn't know what to do. We want to describe that that is height 7. And to clean this up, click on the little wrench. This will get rid of the grid. And now if we wanted to, we could put this in projector mode to make these a little bolder. What we're looking at is this. The blue is our natural log function, and we wanted to figure out what are the x values we can plug in so that the blue function's heights are stuck in between this red line at height -3 and the green line at height 7. And one of the nice things about Desmos is you can click on this and it'll come up with these intersections. So down here, look at this. This is right where that red line hits the blue line. And when we solved it, we got 1 over e to the 3. That's what this value is right here, this 0.05 value. So we see when x is this value, it puts us at that height of -3. And then to see what's going on over here, we need to just zoom out and roll out a little bit because the natural log is a very slow growing function. And we want to figure out what x value causes this thing to hit that green line. So if we just keep on zooming out, oh, right here, finally. Click it. Look, the x value right here is almost 1,900 or 1,097. And if you plug your value of e to the 7th in to a calculator, you'll find that this is exactly the value that they're getting. So what we're finding is, we're finding that our natural log, our blue function, stays in between heights -3 and +7 as long as we are using x values in between 1 divided by e to the 3rd all the way up to e to the 7th power. That's what we're getting from this little exercise with the inequalities and interval notation. Hope you found this helpful and look forward to giving you more helpful solutions in the future. Have a good one. Bye-bye.